So happy evening. I just wanted to do this session as a continuation of our review of the study guide for the exam 2. And we went through the first two chapters, so the heart and the blood vessels, in our morning's live online session. And I figured that this evening, what we can do, we can then instead go through the lymphatic and immune system chapters of the study guide 2. Before I jump into that, just a reminder, you can find the study guide in your weekly learning module. So it's going to be there available for you, and you can either observe it there or download it or print it, whatever works for you. But that would be the place to go for there. And as always, there will be blanks. Those blank areas on the study guide are typically a signal that it's going to be something important, an important term, important concept that I want you to get familiar with. The other thing that I wanted to just kind of gently remind you is that if you are all up to date with your assignments, only thing you need to do this week is to complete your exam 2 and lab practical 2. For those, make sure get those in by the end of the week, so before the end of the Sunday. And if you're considering the lab practical 2 and want to prepare for it, you'll find the lab practical 2 practice under the lab study resources. So that might be something that you might want to consider laying through or working through even multiple times. So what happens in lab practical 2 practice, there's a set of questions. We pull some of them from a larger pool, so you'll always see a little different set of questions. So it might be worth playing it through a couple of times so you see all possible kind of questions that might come up in the practical. In terms of the is it compulsory? Absolutely not. To do the practice practical, that's just a resource that I want to offer to you, but I'm by no means expecting that you absolutely have to do it. So without a further ado, let me pull up the screen where we're gonna see the study guide. And I believe that our morning session kind of finished here on page 28. So we're continuing from page 29, and we'll start by looking at the lymphatic system, then we'll talk about the immune system. One thing that you'll notice is that we have spent majority of this study guide focusing on the heart and blood vessels. That tells you a little bit about the emphasis that we have on the exam as well. So those are really, really important chapters. I'm not saying that lymphatic system and immune system aren't important, but there is a little greater emphasis on the two first chapters. When we look at the lymphatic system, one thing that we'll notice is that it relates nicely to many other chapters that we have discussed. So first of all, it was kind of this complementary system that caught the fluid that leaks out from the cardiovascular system. Like I've told you before, for a longest of time, that cardiovascular is a closed loop system, but we saw that it's actually not as perfectly closed as we tend to teach you. A little bit of fluid leaks out from there, and it's the role of the lymphatic system to catch that fluid and return it back to the circulatory system. Other thing that we notice what the lymphatic system does, it is a set of anatomical structures within which the immune system lives. So immune system was mostly just a physiological system, but it uses the lymphatic system structures to exist, to do its physiological role. So you'll see nicely how these all are connected. Couple of terms that I wanted to emphasize. You do remember this diagram was really good. So we're seeing here blood coming to a capillary. Some of the contents of the blood, especially the contents that would be like our plasma, leak out. due to the hydrostatic pressure. Some of it gets put back in due to the osmotic pressure, but overall there is a net gain outside the capillary in the interstitial space that forms the interstitial fluid, and that then is what our lymphatic system is there to catch. Looking at leaving the capillaries, heading back, we have a little bit less fluid. So now we're dealing with this interstitial fluid. So the terms that we're seeing, the composition is very similar, the plasma of the blood and the interstitial fluid of this space outside the capillary. I like to ask in an exam that when does interstitial fluid become lymph? Well, it becomes lymph when this interstitial fluid gets picked up by the lymphatic system so that it can be dumped back into the cardiovascular system. So when it enters to the lymphatic system is when the interstitial fluid becomes lymph. So be sure that you feel comfortable with that terminology. We've kind of already seen the comparison between lymphatic system and cardiovascular system, both one-way systems, but remember that lymphatic system was open loop, so it was open from one end, so that's how it's able to pick up that lymph. 3 functions that we see for the lymphatic system. First of all, to fight against diseases, against pathogens, so that's an important role, transporting fluid so we don't end up with that extra fluid outside the cardiovascular system and edema forming. So that's another role of the lymphatic system. And final role was the transport of large molecules such as large dietary fats. So we discussed about that in the class. In terms of the lymphatic vessel, we're going to work through the vessel by vessel, going from smallest to the largest. So the end where the lymphatic system is open is going to be at the lymphatic capillaries. So they're open-ended vessels collecting that interstitial fluid around the capillaries. They are very similar to the capillaries that you saw in the cardiovascular system, but the big things to notice is that they are much more permeable than the blood vessel capillaries. They do have the simple squamous endothelia that we saw on the tunica intima. So that again, this easy passage of materials across the membrane. Let's have a look at some of the lymphatic vessels and collecting vessels. So they are thin. We have the same adaptation as we had on the veins, so some valves. So valves facilitate the one-directional flow of the lymph, and anastomosis were those interconnections between the lymphatic vessels that we saw. And I wanted to highlight from the ducts, the thoracic duct, running at the posterior part of the thoracic cavity, kind of along the vertebral column. We saw at the very inferior end of the thoracic duct, at the thoracic cavity, the dilated sac, which was known as cisternaculi. Let's have a look at lymphatic trunks. We're going to bigger structures. So again, named based on their location: lumbar, lower back, intestinal, intercostal, referring to the between the ribs, bronchomediastinal, subclavian below the clavicle, and jugular at the neck throat region. Moving onwards to bigger, we'll see lymphatic ducts. So I've listed there an example of the right lymphatic duct and thoracic duct. So some to be familiar there. If we talk about lymph and what lymph is, we saw that it's very similar to what we saw in terms of the contents of the interstitial fluid. So we have a great amount of water, proteins, and all the other stuff. One thing that we do find that is now very visible is going to be the great content of white blood cells, since the white blood cells were housed within the lymphatic system, especially lymph nodes. One thing you should never see in the lymph is going to be our red blood cells. So a note to make about that. And you do remember lymph was made at the bone marrow and lymph nodes. The clinical relevance that I wanted to mention was the buildup of lymph. If the lymphatic system is not correctly catching that, this could be due to damage of the lymphatic network, for example, due to some sort of an injury or removal of vessels or tumors. So in that case, the drainage is not working successfully. We end up building lymph to an area, and we talk about lymphedema causing the swelling of the region. We did see that that can sometimes spontaneously resolve itself over time, so that is one option. In terms of the lymphatic cells, I'll leave the immune system cells for our next section. So T cells, remember, mature at thymus, B cells mature at bone marrow, and we had, of course, supporting cells. What I do want to spend a little bit of time on this section is to look at the lymph nodes. So remember, these were the kind of smallish, largest about 1 inch in size, bean-shaped glands, often located as clusters within certain area. There's about between 400 to 700 lymph nodes in a typical adult. Their function is twofold: to filter the lymph and house the immune system cells. So these immune system cells, their big goal was to fight the pathogens. When there is an inflammation, the number of white blood cells within the lymph node increases, and as a result, the lymph nodes might swell. So we're looking for that swelling, for the tenderness when the doctor checks your lymph nodes. If they are swollen, tender, that's probably a sign that there's inflammation going on somewhere. A couple of locations where we might find lymph nodes: cervical, at the neck, axillary, armpit, supratrochlear, above the trochlear notch, inguinal, the groin region, abdominal, and thoracic. I did highlight in the class the parts of a lymph node, so cortex, the outer, medulla, the inner, within medulla, sinuses, those openings, empty spaces. In terms of a lymphatic vessels coming to the lymph nodes, remember we had afferent ones bringing lymph into and efferent ones taking lymph away from the lymph node. We did already discuss about this swollen lymph node, so I'll just browse over that. In terms of the lymphatic organs, the first one we had a look at was the largest of the lymphatic organs that we discussed, about a fist-sized in size, located on the left side of the abdominal cavity, just below the stomach. That was our spleen. And remember, there was a rich blood supply to the spleen through splenic artery and splenic vein and all that. You built that nice diagram of the blood vessels of the body, so whoever did the abdominal region probably got to highlight that. The roles of the spleen are varied, multiple. Some of those included removing old or dead or components, breaking it into components of old red blood cells or blood cells in general, platelets, so on. So we can reuse some of the elements, we can replace them. And remember, in an embryo, spleen played an important role in red blood cell production. Of course, you could live without a spleen if you had to lose it. Those functions typically get then just reassigned for your liver and kidneys. Another structure that I did discuss about was our tonsils, and remember that's a group of structures named based on the location. So palatine tonsils at the posterior oral cavity, lingual tonsils at the base of tongue, pharyngeal tonsils at the posterior nasopharynx, and tubal tonsils at the auditory tube. Of course, you could have an inflammation of the tonsils, so tonsillitis. And in certain cases, if this is chronic, we did in the past consider that maybe surgically removing the tonsils in an operation known as tonsillectomy. I also mentioned appendix, the first part of the large intestines coming out from the cecum. We discussed a little bit of its role, potentially evolutionary remained there, and it could get inflamed, it could be removed, so we can live perfectly fine without appendix. Final one I think we discussed a little bit was our thymus. Remember, that was large during your early life and at your puberty, and then gets replaced by connective tissue and adipose tissue. Doesn't mean that thymus stops working though, even though it anatomically kind of becomes a smaller structure. That was all that I had to say about the lymphatic system, and I wanted to spend just a little looking about the immune system. You remember, immune system was more of a functional system, so more about physiology than anything else, and that was housed within the lymphatic system. So we're looking really now of those white blood cells, what they do. Their role is to protect, of course, us against pathogens. Pathogens, what they want to do, they want to get into your body and multiply in great numbers and then go and get somewhere else. So take over the world, like I said, bring Pinky and the Brain, a little bit of a similar agenda. In terms of the immune system, we had two branches or two systems, if you wish. The first one we had a look of was innate immunity, very general responses, very same response for all pathogens, and not as strong of a response, but immediate response. So it was not as specific, it protected against many different types of pathogens. Innate immunity worked through different lines of defense. The first line of defense is to keep the pathogen out from your body. We can do this, for example, through establishing physical barriers, such as your skin or mucous membranes lining the oral cavity, nasal cavity, and so on. So let's not let the pathogen in at all. That would be a good strategy. If that fails, we can recruit the second line defenses, which work through chemicals. Think of eating something that you shouldn't have that might contain a pathogen. Well, stomach acids typically are able to deal with that. Sweat on the skin is really excellent chemical defense mechanism against many bacteria, tears, urination, so on and so on. If the second line failed as well, we could recruit cell responses. So we had our natural killer cells, phagocytic cells, antimicrobial proteins, and so on. I want to highlight especially inflammation and fever from these. So inflammation, the signs and symptoms was red, warm, swollen, painful. And the fifth one that you could add there is the loss of function. Fever, referring to abnormally high body temperature, more of a global in the body response than a local response. The adaptive immunity, acquired immunity, is the branch that we often think of when we talk about that you are immune to something. So this was all about those memory cells. So first time you face the pathogen, adaptive immunity is not that much of a use, but then when you face it the second time, you now have a plan of attack to deal with that pathogen. The response is strong, it's fast, and it's very efficient. So very, very specific response against specific pathogens. We talked about the immunoglobulins a little bit, and we talked about how that could be not naturally or artificially acquired. I also included into your lecture videos a little bit about pathological states, allergies, immune deficiencies, autoimmune diseases, hypersensitivities, all that sort of stuff as it relates to immune system. So you can refer back to there if you want to look through it. And I think that that completes everything that I had for the study guide in terms of lymphatic and immune system. So I guess that the only thing I have left to share or remind you is, let me jump back in to share this screen. Is, like I said, make sure you get the tests done, the exam and lab practical. And in terms of the lab practical, I strongly encouraged you to practice it a little bit ahead of the time through that lab practical to practice. It's not compulsory, but that might help you if you're kind of wondering where to go. So that's all I have for this week. Remember, if you had any missing assignments, this was a good week to catch up on those. If you've sent me a message or asked me to reopen something, I'll try to get them open tomorrow. I'll give you plenty of time to catch up on those, but I'll try to make sure that you have those access tomorrow. Next week, we'll have a look of the respiratory system. So we'll talk about, it's going to be much more concrete. It's going to be a lot more structures that you can see that it ties in very nicely with our discussion about the cardiovascular system and especially the blood and vasculature of the pulmonary circulation. So I expect it to be a fun week. And after that, I believe it's time for our spring break, which is very exciting. At least I'm very much looking forward to it, and I hope you have great plans in making for that. Having said all that, I think that that about wraps it up from me for today. I really do appreciate if you joined me, whether it was in person or through a recording, for this quick review of the study guide, and I will see you again next week. Remember, I'm always here to help you, so don't hesitate to drop me a message, reach out to me. We'll make sure that you're gonna succeed on this class. And as always, I appreciate you being part of this course. Have a good rest of the evening. That's it for me for now. Bye.